Welcome to the 2-Bit Electronics channel. All of your wildest fantasies will come true here. It's probably the best content on the internet. Don't forget to subscribe. You'll learn lots of stuff. Thanks for watching.
Get ready. Here comes a snooze alert. This is the Python Glossary. Its version something or other. Glossary. The default Python prompt of the interactive shell. Often seen for code examples which can be executed interactively in the interpreter. Can refer to the default Python prompt of the interactive shell when entering the code for an indented code block, when within a pair of matching left and right delimiters, parentheses, square brackets, curly braces, or triple quotes, or after specifying a decorator. The ellipsis built-in constant. Abstract base class. Abstract base classes complement duck typing by providing a way to define interfaces when other techniques like hash-adr would be clumsy or subtly wrong, for example with magic methods. ABCs introduce virtual subclasses, which are classes that don't inherit from a class but are still recognized by isInstance, and is subclass. See the ABC module documentation. Python comes with many built-in ABCs for data structures, in the collections.abc module, numbers, in the numbers module, streams, in the IO module, import finders and loaders, in the importlib.abc module. You can create your own ABCs with the ABC module. Annotation. A label associated with a variable, a class attribute or a function parameter or return value, used by convention as a type hint. Annotations of local variables cannot be accessed at runtime, but annotations of global variables, class attributes, and functions are stored in the __annotations __ special attribute of modules, classes, and functions, respectively. See variable annotation, function annotation, PEP 484 and PEP 526, which describe this functionality. Also see annotations best practices for best practices on working with annotations. Argument. A value passed to a function, or method, when calling the function. There are two kinds of argument. Keyword argument, an argument preceded by an identifier, e.g. name equals in a function call or passed as a value in a dictionary preceded by. For example, 3 and 5 are both keyword arguments in the following calls to complex. Complex, real equals 3, imag equals 5. Complex, real, 3, imag, 5. Positional argument, an argument that is not a keyword argument. Positional arguments can appear at the beginning of an argument list and / or be passed as elements of an iterable preceded by star. For example, 3 and 5 are both positional arguments in the following calls. Complex, 3, 5. Complex, asterisk, 3, 5. Arguments are assigned to the named local variables in a function body. See the calls section for the rules governing this assignment. Syntactically, any expression can be used to represent an argument. The evaluated value is assigned to the local variable. See also the parameter glossary entry, the FAQ question on the difference between arguments and parameters, and PEP 362. Asynchronous context manager. An object which controls the environment seen in an async with statement by defining __enter ___ and __exit ___ methods. Introduced by PEP 492. Asynchronous generator. A function which returns an asynchronous generator iterator. It looks like a coroutine function defined with async def except that it contains yield expressions for producing a series of values usable in an async for loop. Usually refers to an asynchronous generator function, but may refer to an asynchronous generator iterator in some contexts. In cases where the intended meaning isn't clear, using the full terms avoids ambiguity. An asynchronous generator function may contain await expressions as well as async for, and async with statements. Asynchronous generator iterator. An object created by asynchronous generator function. This is an asynchronous iterator which when called using the __next__ method returns an awaitable object which will execute the body of the asynchronous generator function until the next yield expression. Each yield temporarily suspends processing, remembering the location execution state, including local variables and pending try statements. When the asynchronous generator iterator effectively resumes with another awaitable returned by __next__, it picks up where it left off. See PEP 492 and PEP 525. Asynchronous iterable. An object, that can be used in an async for statement, must return an asynchronous iterator from its __iter___ method. Introduced by PEP 492. Asynchronous iterator. An object that implements the __iter__ and __next__ methods. A next__ must return an awaitable object. Async for resolves the awaitables returned by an asynchronous iterator's __next__ method until it raises a stop async iteration exception. Introduced by PEP 492. Attribute. A value associated with an object which is usually referenced by name using dotted expressions. For example, if an object O has an attribute A, it would be referenced as OA. It is possible to give an object an attribute whose name is not an identifier as defined by identifiers and keywords, for example using ctadr, if the object allows it. Such an attribute will not be accessible using a dotted expression, and would instead need to be retrieved with getItr. Awaitable. An object that can be used in an await expression. Can be a coroutine or an object with an __await___ method. See also PEP 492. BDFL. Benevolent Dictator for Life, aka Guido van Rossum, Python's creator. Binary file. A file object able to read and write bytes-like objects. Examples of binary files are files opened in binary mode, RB, WB, or RB+, sys.stin.buffer, sys.stout.buffer, and instances of io.bytes io and xip.zip file. See also text file for a file object able to read and write str objects. Borrowed reference. In Python C API, a borrowed reference is a reference to an object, where the code using the object does not own the reference. It becomes a dangling pointer if the object is destroyed. For example, a garbage collection can remove the last strong reference to the object and so destroy it. Calling py_incref on the borrowed reference is recommended to convert it to a strong reference in place, except when the object cannot be destroyed before the last usage of the borrowed reference. The py_enrave function can be used to create a new strong reference. Bytes-like object. An object that supports the buffer protocol and can export a C-contiguous buffer. This includes all bytes, byte array, and array.array objects, as well as many common memory view objects. Bytes-like objects can be used for various operations that work with binary data. These include compression, saving to a binary file, and sending over a socket. Some operations need the binary data to be mutable. The documentation often refers to these as read-write bytes-like objects. Example mutable buffer objects include byte array and a memory view of a byte array. Other operations require the binary data to be stored in immutable objects, read-only bytes-like objects. Examples of these include bytes and a memory view of a bytes object. Bytecode. Python source code is compiled into bytecode, the internal representation of a Python program in the CPython interpreter. The bytecode is also cached in .pyc files so that executing the same file is faster the second time. Recompilation from source to bytecode can be avoided. This intermediate language is said to run on a virtual machine that executes the machine code corresponding to each bytecode. Do note that bytecodes are not expected to work between different Python virtual machines. nor to be stable between Python releases. A list of bytecode instructions can be found in the documentation for the DIS module. Callable. A callable is an object that can be called, possibly with a set of arguments, see argument, with the following syntax. Callable, argument 1, argument 2, argument n. A function, and by extension a method, is a callable. An instance of a class that implements the __call__ method is also a callable. Callback. A subroutine function which is passed as an argument to be executed at some point in the future. Class. A template for creating user-defined objects. Class definitions normally contain method definitions which operate on instances of the class. Class variable. A variable defined in a class and intended to be modified only at class level, i.e., not in an instance of the class. Closure variable. A free variable referenced from a nested scope that is defined in an outer scope rather than being resolved at runtime from the globals or built-in namespaces. May be explicitly defined with the non-local keyword to allow write access, or implicitly defined if the variable is only being read. For example, in the inner function in the following code, both x and print are free variables, but only x is a closure variable. Def outer. X equals 0. Def inner. Non-local x. X plus equals 1. Print, x. Return inner. Due to the code object.co_freevars attribute, which, despite its name, only includes the names of closure variables rather than listing all referenced free variables, the more general free variable term is sometimes used even when the intended meaning is to refer specifically to closure variables. Complex number. An extension of the familiar real number system in which all numbers are expressed as a sum of a real part and an imaginary part. Imaginary numbers are real multiples of the imaginary unit, the square root of -1, often written I in mathematics or J in engineering. Python has built-in support for complex numbers, which are written with this latter notation. The imaginary part is written with a j suffix, example 3 plus 1j. To get access to complex equivalents of the math module, use CMath. Use of complex numbers is a fairly advanced mathematical feature. If you're not aware of a need for them, it's almost certain you can safely ignore them. Context. This term has different meanings depending on where and how it is used. Some common meanings. The temporary state or environment established by a context manager via a with statement. The collection of key-value bindings associated with a particular context vars.context object and accessed via context var objects. Also see context variable. A context vars.context object. Also see current context. Context management protocol. The __enter__, and __exit__, methods called by the with statement. CPEP 343. Context Manager. An object which implements the context management protocol and controls the environment seen in a with statement. CPEP 343. Context Variable. A variable whose value depends on which context is the current context. Values are accessed via context vars.context var objects. Context variables are primarily used to isolate state between concurrent asynchronous tasks. Contiguous. A buffer is considered contiguous exactly if it is either C-contiguous or Fortran contiguous. Zero-dimensional buffers are C and Fortran contiguous. In one-dimensional arrays, the items must be laid out in memory next to each other, in order of increasing indexes starting from 0. In multidimensional C-contiguous arrays, the last index varies the fastest when visiting items in order of memory address. However, in Fortran contiguous arrays, the first index varies the fastest. Coroutine. Coroutines are a more generalized form of subroutines. Subroutines are entered at one point and exited at another point. Coroutines can be entered, exited, and resumed at many different points. They can be implemented with the async def statement. See also PEP 492. Coroutine function. A function which returns a coroutine object. A coroutine function may be defined with the async def statement, and may contain await, async for, and async with keywords. These were introduced by PEP 492. See Python. The canonical implementation of the Python programming language, as distributed on python.org. The term CPython is used when necessary to distinguish this implementation from others such as Jython or IronPython. Current context. The context vars.context object, that is currently used by context var objects to access, get or set, the values of context variables. Each thread has its own current context. Frameworks for executing asynchronous tasks, see Asyncio, associate each task with a context which becomes the current context whenever the task starts or resumes execution. Decorator. A function returning another function, usually applied as a function transformation using the @wrapper syntax. Common examples for decorators are class method, and static method. The decorator syntax is merely syntactic sugar. The following two function definitions are semantically equivalent. Def f, arg. F equals static method, f. @static method. Def f, arg. The same concept exists for classes, but is less commonly used there. See the documentation for function definitions and class definitions for more about decorators. Descriptor. Any object which defines the methods __get __, set __, or delete ___. When a class attribute is a descriptor, its special binding behavior is triggered upon attribute lookup. Normally, using a.b to get, set, or delete an attribute looks up the object named b in the class dictionary for a, but if b is a descriptor, the respective descriptor method gets called. Understanding descriptors is a key to a deep understanding of Python because they are the basis for many features including functions, methods, properties, class methods, static methods, and reference to superclasses. For more information about descriptors methods, see Implementing Descriptors or the Descriptor How-To Guide. Dictionary. An associative array, where arbitrary keys are mapped to values. The keys can be any object with ___, ___, and ___, methods. Called a hash in Perl. Dictionary comprehension. A compact way to process all or part of the elements in an iterable and return a dictionary with the results. Results equals n, n2 for n in range, 10, generates a dictionary containing key n mapped to value n2. See displays for lists, sets and dictionaries. Dictionary view. The objects returned from dict.keys, dict.values, and dict.items, are called dictionary views. They provide a dynamic view on the dictionary's entries, which means that when the dictionary changes, the view reflects these changes. To force the dictionary view to become a full list, use list, dict view. See dictionary view objects. Docstring. A string literal which appears as the first expression in a class, function, or module. While ignored when the suite is executed, it is recognized by the compiler and put into the __doc__ attribute of the enclosing class, function, or module. Since it is available via introspection, it is the canonical place for documentation of the object. Duck typing. A programming style which does not look at an object's type to determine if it has the right interface. Instead, the method or attribute is simply called or used. If it looks like a duck and quacks like a duck, it must be a duck. By emphasizing interfaces rather than specific types. Well-designed code improves its flexibility by allowing polymorphic substitution. Duck typing avoids tests using type, or isinstance. Note, however, that duck typing can be complemented with abstract base classes. Instead, it typically employs hasadr, tests or EAFP programming. EAFP. Easier to ask for forgiveness than permission. This common Python coding style assumes the existence of valid keys or attributes and catches exceptions if the assumption proves false. This clean and fast style is characterized by the presence of many try and except statements. The technique contrasts with the LBYL style common to many other languages such as C. Expression. A piece of syntax which can be evaluated to some value. In other words, an expression is an accumulation of expression elements like literals, names, attribute access, operators, or function calls which all return a value. In contrast to many other languages, not all language constructs are expressions. There are also statements which cannot be used as expressions, such as while. Assignments are also statements, not expressions. Extension module. A module written in C or C++, using Python C API to interact with the core and with user code. F-string. String literals prefixed with F or F are commonly called F-strings, which is short for formatted string literals. See also PEP 498. File object. An object exposing a file-oriented API, with methods such as read, or write, to an underlying resource. Depending on the way it was created, a file object can mediate access to a real on-disk file or to another type of storage or communication device, for example standard input/output, in-memory buffers, sockets, pipes, etc. File objects are also called file-like objects or streams. There are actually three categories of file objects: raw binary files, buffered binary files, and text files. Their interfaces are defined in the I/O module. The canonical way to create a file object is by using the open function. File-like object. A synonym for file object. File system encoding and error handler. Encoding and error handler used by Python to decode bytes from the operating system and encode Unicode to the operating system. The file system encoding must guarantee to successfully decode all bytes below 128. If the file system encoding fails to provide this guarantee, API functions can raise Unicode error. The sys.getFileSystemEncoding and sys.getFileSystemEncodeErrors functions can be used to get the file system encoding and error handler. The file system encoding and error handler are configured at Python startup by the pconfig_read function. See file system_encoding and file system_errors members of pyconfig. See also the locale encoding. Finder. An object that tries to find the loader for a module that is being imported. There are two types of finder: meta path finders for use with sys.meta_path, and path entry finders for use with sys.path_hooks. See finders and loaders and import lib for much more detail. Floor division. Mathematical division that rounds down to nearest integer. The floor division operator is //. For example, the expression 11//4 evaluates to 2 in contrast to the 2.75 returned by float true division. Note that, -11//4 is -3 because that is -2.75 rounded downward. See PEP 238. Free threading. A threading model where multiple threads can run Python bytecode simultaneously within the same interpreter. This is in contrast to the global interpreter lock, which allows only one thread to execute Python bytecode at a time. See PEP 703. Free variable. Formally, as defined in the language execution model, a free variable is any variable used in a namespace which is not a local variable in that namespace. See closure variable for an example. Pragmatically, due to the name of the code object.co_freevars attribute, the term is also sometimes used as a synonym for closure variable. Function. A series of statements which returns some value to a caller. It can also be passed 0 or more arguments which may be used in the execution of the body. See also parameter, method, and the function definitions section. Function annotation. An annotation of a function parameter or return value. Function annotations are usually used for type hints. For example, this function is expected to take two int arguments and is also expected to have an int return value. Def sum underscore two underscore numbers, a, int, b, int, int. Return a plus b. Function annotation syntax is explained in section function definitions. See variable annotation and PEP 484, which describe this functionality. Also see annotations best practices for best practices on working with annotations. Future underscore underscore. A future statement, from underscore underscore future underscore underscore import feature, directs the compiler to compile the current module using syntax or semantics that will become standard in a future release of Python. The underscore underscore future underscore underscore module documents the possible values of feature. By importing this module and evaluating its variables, you can see when a new feature was first added to the language and when it will, or did, become the default. Import underscore underscore future underscore underscore. Future underscore underscore dot division. Feature, 2, 2, 0, alpha, 2, 3, 0, 0, alpha, 0, 8192. Garbage collection. The process of freeing memory when it is not used anymore. Python performs garbage collection via reference counting and a cyclic garbage collector that is able to detect and break reference cycles. The garbage collector can be controlled using the GC module. Generator. A function which returns a generator iterator. It looks like a normal function except that it contains yield expressions for producing a series of values usable in a for loop or that can be retrieved one at a time with the next function. Usually refers to a generator function, but may refer to a generator iterator in some contexts. In cases where the intended meaning isn't clear, using the full terms avoids ambiguity. Generator iterator. An object created by a generator function. Each yield temporarily suspends processing, remembering the location execution state, including local variables and pending try statements. When the generator iterator resumes, it picks up where it left off, in contrast to functions which start fresh on every invocation. Generator expression. An expression that returns an iterator. It looks like a normal expression followed by a for clause defining a loop variable, range, and an optional if clause. The combined expression generates values for an enclosing function. Sum, I*I for I in range, 10, hashtag sum of squares 0, 1, 4. 81. 285. Generic function. A function composed of multiple functions implementing the same operation for different types. Which implementation should be used during a call is determined by the dispatch algorithm. See also the single dispatch glossary entry, the functools.single dispatch, decorator, and PEP 443. Generic type. A type that can be parameterized, typically a container class such as list or dict. Used for type hints and annotations. For more details, see generic alias types, PEP 483, PEP 484, PEP 585, and the typing module. GIL. See Global Interpreter Lock. Global Interpreter Lock. The mechanism used by the CPython interpreter to assure that only one thread executes Python bytecode at a time. This simplifies the CPython implementation by making the object model, including critical built-in types such as dict, implicitly safe against concurrent access. Locking the entire interpreter makes it easier for the interpreter to be multi-threaded, at the expense of much of the parallelism afforded by multiprocessor machines. However, some extension modules, either standard or third-party, are designed so as to release the GIL when doing computationally intensive tasks such as compression or hashing. Also, the GIL is always released when doing I/O. As of Python 3.13, the GIL can be disabled using the Disable GIL build configuration. After building Python with this option, code must be run with xgil equals 0 or after setting the python_gil equals 0 environment variable. This feature enables improved performance for multi-threaded applications and makes it easier to use multi-core CPUs efficiently. For more details, see PEP 703. Hash-based PYC. A bytecode cache file that uses the hash rather than the last modified time of the corresponding source file to determine its validity. See cached bytecode invalidation. Hashable. An object is hashable if it has a hash value which never changes during its lifetime. It needs a __hash___ method, and can be compared to other objects. It needs an __eq___ method. Hashable objects which compare equal must have the same hash value. Hashability makes an object usable as a dictionary key and a set member, because these data structures use the hash value internally. Most of Python's immutable built-in objects are hashable. Mutable containers, such as lists or dictionaries, are not. Immutable containers, such as tuples and frozen sets, are only hashable if their elements are hashable. Objects which are instances of user-defined classes are hashable by default. They all compare unequal, except with themselves, and their hash value is derived from their ID. Idle. An integrated development and learning environment for Python. Idle is a basic editor and interpreter environment which ships with the standard distribution of Python. Immortal. Immortal objects are a CPython implementation detail introduced in PEP 683. If an object is immortal, its reference count is never modified, and therefore it is never deallocated while the interpreter is running. For example, true and none are immortal in CPython. Immutable. An object with a fixed value. Immutable objects include numbers, strings, and tuples. Such an object cannot be altered. A new object has to be created if a different value has to be stored. They play an important role in places where a constant hash value is needed, for example as a key in a dictionary. Import path. A list of locations, or path entries, that are searched by the path-based finder for modules to import. During import, this list of locations usually comes from sys.path, but for sub-packages it may also come from the parent packages __path__ attribute. Importing. The process by which Python code in one module is made available to Python code in another module. Importer. An object that both finds and loads a module, both a finder and loader object. Interactive. Python has an interactive interpreter, which means you can enter statements and expressions at the interpreter prompt, immediately execute them and see their results. Just launch Python with no arguments, possibly by selecting it from your computer's main menu. It is a very powerful way to test out new ideas or inspect modules and packages. Remember help, X. For more on interactive mode, see interactive mode. Interpreted. Python is an interpreted language, as opposed to a compiled one, though the distinction can be blurry because of the presence of the bytecode compiler. This means that source files can be run directly without explicitly creating an executable which is then run. Interpreted languages typically have a shorter development/debug cycle than compiled ones, though their programs generally also run more slowly. See also interactive. Interpreter shutdown. When asked to shut down, the Python interpreter enters a special phase where it gradually releases all allocated resources, such as modules and various critical internal structures. It also makes several calls to the garbage collector. This can trigger the execution of code in user-defined destructors or weaker F callbacks. Code executed during the shutdown phase can encounter various exceptions as the resources it relies on may not function anymore. Common examples are library modules or the warnings machinery. The main reason for interpreter shutdown is that the __main __ module or the script being run has finished executing. Iterable. An object capable of returning its members one at a time. Examples of iterables include all sequence types, such as list, str, and tuple, and some non-sequence types like dict, file objects, and objects of any classes you define with an __iter___ method or with a __getItem__ method that implements sequence semantics. Iterables can be used in a for loop and in many other places where a sequence is needed, zip, map. When an iterable object is passed as an argument to the built-in function iter, it returns an iterator for the object. This iterator is good for one pass over the set of values. When using iterables, it is usually not necessary to call iter, or deal with iterator objects yourself. The for statement does that automatically for you, creating a temporary unnamed variable to hold the iterator for the duration of the loop. See also iterator, sequence, and generator. Iterator. An object representing a stream of data. Repeated calls to the iterators __next___ method, or passing it to the built-in function next, return successive items in the stream. When no more data are available, a stop iteration exception is raised instead. At this point, the iterator object is exhausted and any further calls to its __next___ method just raise stop iteration again. Iterators are required to have an __iter__ method that returns the iterator object itself, so every iterator is also iterable and may be used in most places where other iterables are accepted. One notable exception is code which attempts multiple iteration passes. A container object, such as a list, produces a fresh new iterator each time you pass it to the iter function or use it in a for loop. Attempting this with an iterator will just return the same exhausted iterator object used in the previous iteration pass, making it appear like an empty container. More information can be found in iterator types. See Python implementation detail. CPython does not consistently apply the requirement that an iterator define __iter__. And also please note that the free threading CPython does not guarantee the thread safety of iterator operations. Key function. A key function or collation function is a callable that returns a value used for sorting or ordering. For example, locale.strxfrm is used to produce a sort key that is aware of locale-specific sort conventions. A number of tools in Python accept key functions to control how elements are ordered or grouped. They include min, max, sorted, list.sort, heap.merge, heap.nsmallest, heap.nlargest, and itertools.groupby. There are several ways to create a key function. For example, the strlower method can serve as a key function for case-insensitive sorts. Alternatively, a key function can be built from a lambda expression such as lambda r, r0, r2. Also, operator.iterator, operator.itemGetter, and operator.methodCaller are three key function constructors. See the sorting how-to for examples of how to create and use key functions. Keyword argument. See argument. Lambda. An anonymous inline function consisting of a single expression which is evaluated when the function is called. The syntax to create a lambda function is lambda parameters, expression. LBYL. Look before you leap. This coding style explicitly tests for preconditions before making calls or lookups. This style contrasts with the EAFP approach and is characterized by the presence of many if statements. In a multi-threaded environment, the LBYL approach can risk introducing a race condition between the looking and the leaping. For example, the code, if key in mapping, return mapping key can fail if another thread removes key from mapping after the test, but before the lookup. This issue can be solved with locks or by using the EAFP approach. List. A built-in Python sequence. Despite its name, it is more akin to an array in other languages than to a linked list since access to elements is O1. List comprehension. A compact way to process all or part of the elements in a sequence and return a list with the results. Result equals $#04x.format, x, 4x in range, 256, if x%2 equals 0 generates a list of strings containing even hex numbers, 0x. In the range from 0 to 255. The if clause is optional. If omitted, all elements in range, 256, are processed. Loader. An object that loads a module. It must define a method named load_module. A loader is typically returned by a finder. See also finders and loaders. Import lib.abc.loader. PEP 302. Locale encoding. On Unix, it is the encoding of the LC_type locale. It can be set with locale.setLocale, locale.lc_type, new_locale. On Windows, it is the ANSI code page, X, CP1252. On Android and VxWorks, Python uses UTF-8 as the locale encoding. Locale.getEncoding can be used to get the locale encoding. See also the file system encoding and error handler. Magic method. An informal synonym for special method. Mapping. A container object that supports arbitrary key lookups and implements the methods specified in the collections.abc.mapping or collections.abc.mutable mapping abstract base classes. Examples include dict, collections.defaultDict, collections.orderDict and collections.counter. Meta pathfinder. A finder returned by a search of sys.meta_path. Meta pathfinders are related to, but different from path entry finders. See import lib.abc.metapathfinder for the methods that meta pathfinders implement. Metaclass. The class of a class. Class definitions create a class name, a class dictionary, and a list of base classes. The metaclass is responsible for taking those three arguments and creating the class. Most object-oriented programming languages provide a default implementation. What makes Python special is that it is possible to create custom metaclasses. Most users never need this tool, but when the need arises, metaclasses can provide powerful, elegant solutions. They have been used for logging attribute access, adding thread safety, tracking object creation, implementing singletons, and many other tasks. More information can be found in metaclasses. Method. A function which is defined inside a class body. If called as an attribute of an instance of that class, the method will get the instance object as its first argument, which is usually called self. See function and nested scope. Method resolution order. Method resolution order is the order in which base classes are searched for a member during lookup. See the Python 2.3 method resolution order for details of the algorithm used by the Python interpreter since the 2.3 release. Module. An object that serves as an organizational unit of Python code. Modules have a namespace containing arbitrary Python objects. Modules are loaded into Python by the process of importing. See also package. Module spec. A namespace containing the import-related information used to load a module. An instance of import lib.machinery.module_spec. See also module specs. MRO. See method resolution order. Mutable. Mutable objects can change their value but keep their ID. See also immutable. Name tuple. The term name tuple applies to any type or class that inherits from tuple and whose indexable elements are also accessible using named attributes. The type or class may have other features as well. Several built-in types are named tuples, including the values returned by time.localTime, and os.stat. Another example is sys.float_info. sys.float_info 1 #indexed access. 1024. sys.float_info.max_exp hashtag named field access. 1024. Isinstance, sys.float_info, tuple, hashtag kind of tuple. True. Some named tuples are built-in types, such as the above examples. Alternatively, a named tuple can be created from a regular class definition that inherits from tuple and that defines named fields. Such a class can be written by hand, or it can be created by inheriting typing.nameTuple, or with the factory function collections.nameTuple. The latter techniques also add some extra methods that may not be found in handwritten or built-in named tuples. Namespace. The place where a variable is stored. Namespaces are implemented as dictionaries. There are the local, global, and built-in namespaces as well as nested namespaces in objects, in methods. Namespaces support modularity by preventing naming conflicts. For instance, the functions builtins.open and os.open are distinguished by their namespaces. Namespaces also aid readability and maintainability by making it clear which module implements a function. For instance, writing random.seed, or itertools.ilis, makes it clear that those functions are implemented by the random and itertools modules, respectively. Namespace package. A PEP 420 package which serves only as a container for sub-packages. Namespace packages may have no physical representation, and specifically are not like a regular package because they have no __init__.py file. See also module. Nested scope. The ability to refer to a variable in an enclosing definition. For instance, a function defined inside another function can refer to variables in the outer function. Note that nested scopes by default work only for reference and not for assignment. Local variables both read and write in the innermost scope. Likewise, global variables read and write to the global namespace. The non-local allows writing to outer scopes. New style class. Old name for the flavor of classes now used for all class objects. In earlier Python versions, only new style classes could use Python's newer, versatile features like __slots __, descriptors, properties, __getAttribute __, class methods, and static methods. Object. Any data with state, attributes or value, and defined behavior, methods. Also the ultimate base class of any new style class. Optimized scope. A scope where target local variable names are reliably known to the compiler when the code is compiled, allowing optimization of read and write access to these names. The local namespaces for functions, generators, coroutines, comprehensions, and generator expressions are optimized in this fashion. Note, most interpreter optimizations are applied to all scopes, only those relying on a known set of local and non-local variable names are restricted to optimized scopes. Package. A Python module which can contain submodules or recursively, sub-packages. Technically, a package is a Python module with a __path___ attribute. See also regular package and namespace package. Parameter. A named entity in a function, or method, definition that specifies an argument, or in some cases, arguments, that the function can accept. There are 5 kinds of parameter. Positional or keyword, specifies an argument that can be passed either positionally or as a keyword argument. This is the default kind of parameter, for example foo and bar in the following. Def func, foo, bar equals none. Positional only, specifies an argument that can be supplied only by position. Positional-only parameters can be defined by including a / character in the parameter list of the function definition after them, for example positionally1 and positionally2 in the following. Def func, positionally1, positionally2, / positional_or keyword. Keyword only, specifies an argument that can be supplied only by keyword. Keyword-only parameters can be defined by including a single var positional parameter or bare asterisk in the parameter list of the function definition before them, for example kw_only1 and kw_only2 in the following. Def func, arg, asterisk, kw_only1, kw_only2. Var positional, specifies that an arbitrary sequence of positional arguments can be provided, in addition to any positional arguments already accepted by other parameters. Such a parameter can be defined by prepending the parameter name with asterisk, for example args in the following. Def func, asterisk args, quargs. Var keyword, specifies that arbitrarily many keyword arguments can be provided, in addition to any keyword arguments already accepted by other parameters. Such a parameter can be defined by prepending the parameter name with, for example quargs in the example above. Parameters can specify both optional and required arguments, as well as default values for some optional arguments. See also the argument glossary entry, the FAQ question on the difference between arguments and parameters, the inspect.parameter class, the function definitions section, and PEP 362. Path entry. A single location on the import path which the path-based finder consults to find modules for importing. Path entry finder. A finder returned by a callable on sys.path_hooks, i.e. a path entry hook, which knows how to locate modules given a path entry. See import lib.abc.pathEntryFinder for the methods that path entry finders implement. Path entry hook. A callable on the sys.path_hooks list which returns a path entry finder if it knows how to find modules on a specific path entry. Path-based finder. One of the default meta path finders which searches an import path for modules. Path-like object. An object representing a file system path. A path-like object is either a str or bytes object representing a path, or an object implementing the os.path-like protocol. An object that supports the os.path-like protocol can be converted to a str or bytes file system path by calling the os.fspath function, os.fsdecode, and os.fsencode, can be used to guarantee a str or bytes result instead, respectively. Introduced by PEP 519. PEP. Python Enhancement Proposal. A PEP is a design document providing information to the Python community, or describing a new feature for Python or its processes or environment. PEPs should provide a concise technical specification and a rationale for proposed features. PEPs are intended to be the primary mechanisms for proposing major new features, for collecting community input on an issue, and for documenting the design decisions that have gone into Python. The PEP author is responsible for building consensus within the community and documenting dissenting opinions. See PEP 1. Portion. A set of files in a single directory, possibly stored in a zip file, that contribute to a namespace package, as defined in PEP 420. Positional argument. See argument. Provisional API. A provisional API is one which has been deliberately excluded from the standard library's backwards compatibility guarantees. While major changes to such interfaces are not expected, as long as they are marked provisional, backwards incompatible changes, up to and including removal of the interface, may occur if deemed necessary by core developers. Such changes will not be made gratuitously, they will occur only if serious fundamental flaws are uncovered that were missed prior to the inclusion of the API. Even for provisional APIs, backwards incompatible changes are seen as a solution of last resort. Every attempt will still be made to find a backwards compatible resolution to any identified problems. This process allows the standard library to continue to evolve over time, without locking in problematic design errors for extended periods of time. See PEP 411 for more details. Provisional package. See Provisional API. Python 3000. Nickname for the Python 3.x release line, coined long ago when the release of version 3 was something in the distant future. This is also abbreviated Py3K. Pythonic. An idea or piece of code which closely follows the most common idioms of the Python language, rather than implementing code using concepts common to other languages. For example, a common idiom in Python is to loop over all elements of an iterable using a for statement. Many other languages don't have this type of construct, so people unfamiliar with Python sometimes use a numerical counter instead. For I in range, len, food. Print, food I. As opposed to the cleaner, Pythonic method. For piece in food. Print, piece. Qualified name. A dotted name showing the path from a module's global scope to a class, function, or method defined in that module, as defined in PEP 3155. For top-level functions and classes, the qualified name is the same as the object's name. Class C. Class D. Def meth, self. Pass. C __ quil name __ C. C.D __ quil name __ C.D. C.D.meth __ quil name __ C.D.meth. When used to refer to modules, the fully qualified name means the entire dotted path to the module, including any parent packages, e.g. email.mime.txt. Import email.mime.txt. Email.mime.txt __ name __ Email.mime.txt. Reference count. The number of references to an object. When the reference count of an object drops to 0, it is deallocated. Some objects are immortal and have reference counts that are never modified, and therefore the objects are never deallocated. Reference counting is generally not visible to Python code, but it is a key element of the C Python implementation. Programmers can call the sys.getRefCount function to return the reference count for a particular object. Regular package. A traditional package, such as a directory containing an __init__.py file. See also namespace package. Replace. An acronym for the read, eval, print loop, another name for the interactive interpreter shell. Slots __. A declaration inside a class that saves memory by pre-declaring space for instance attributes and eliminating instance dictionaries. Though popular, the technique is somewhat tricky to get right and is best reserved for rare cases where there are large numbers of instances in a memory-critical application. Sequence. An iterable which supports efficient element access using integer indices via the __getitem__, special method and defines a __len__ method that returns the length of the sequence. Some built-in sequence types are list, str, tuple, and bytes. Note that dict also supports __getitem__, and __len__, but is considered a mapping rather than a sequence because the lookups use arbitrary hashable keys rather than integers. The collections.abc.sequence abstract base class defines a much richer interface that goes beyond just __getitem__, and __len__, adding count, index, ___ contains ___, and ___ reversed ___. Types that implement this expanded interface can be registered explicitly using register. For more documentation on sequence methods generally, see common sequence operations. Set comprehension. A compact way to process all or part of the elements in an iterable and return a set with the results. Results equal C for C in abracadabra if C not in ABC generates the set of strings R, D. C displays for lists, sets and dictionaries. Single dispatch. A form of generic function dispatch where the implementation is chosen based on the type of a single argument. Slice. An object usually containing a portion of a sequence. A slice is created using the subscript notation, with colons between numbers when several are given, such as in variable underscore name 1:3:5. The bracket, subscript, notation uses slice objects internally. Soft deprecated. A soft deprecated API should not be used in new code, but it is safe for already existing code to use it. The API remains documented and tested, but will not be enhanced further. Soft deprecation, unlike normal deprecation, does not plan on removing the API and will not emit warnings. CPEP 387, Soft deprecation. Special method. A method that is called implicitly by Python to execute a certain operation on a type, such as addition. Such methods have names starting and ending with double underscores. Special methods are documented in special method names. Statement. A statement is part of a suite, a block of code. A statement is either an expression or one of several constructs with a keyword, such as if, while, or for. Static type checker. An external tool that reads Python code and analyzes it, looking for issues such as incorrect types. See also type hints and the typing module. Strong reference. In Python C API, a strong reference is a reference to an object which is owned by the code holding the reference. The strong reference is taken by calling pi_decref, when the reference is created, and released with pi_decref, when the reference is deleted. The pi_ref function can be used to create a strong reference to an object. Usually, the pi_decref function must be called on the strong reference before exiting the scope of the strong reference, to avoid leaking one reference. See also borrowed reference. Text encoding. A string in Python is a sequence of Unicode code points, in range U+0000, U+10FFFF. To store or transfer a string, it needs to be serialized as a sequence of bytes. Serializing a string into a sequence of bytes is known as encoding, and recreating the string from the sequence of bytes is known as decoding. There are a variety of different text serialization codecs, which are collectively referred to as text encodings. Text file. A file object able to read and write str objects. Often, a text file actually accesses a byte-oriented data stream and handles the text encoding automatically. Examples of text files are files opened in text mode, R or W, sys.stin, sys.stout, and instances of io.string io. See also binary file for a file object able to read and write bytes-like objects. Triple quoted string. A string which is bound by three instances of either a quotation mark, or an apostrophe. While they don't provide any functionality not available with single quoted strings, they are useful for a number of reasons. They allow you to include unscaped single and double quotes within a string, and they can span multiple lines without the use of the continuation character, making them especially useful when writing docstrings. Type. The type of a Python object determines what kind of object it is. Every object has a type. An object's type is accessible as its __class __ attribute, or can be retrieved with type, obj. Type alias. A synonym for a type, created by assigning the type to an identifier. Type aliases are useful for simplifying type hints. For example, def remove _gray shades. Colors, list tuple int, list tuple int. Pass. Could be made more readable like this. Color equals tuple int. Def remove _gray shades, colors, list color. Pass. See typing and PEP 484, which describe this functionality. Type hint. An annotation that specifies the expected type for a variable, a class attribute, or a function parameter or return value. Type hints are optional and are not enforced by Python, but they are useful to static type checkers. They can also aid IDEs with code completion and refactoring. Type hints of global variables, class attributes, and functions, but not local variables, can be accessed using typing.get_type_hints. See typing and PEP 484, which describe this functionality. Universal new lines. A manner of interpreting text streams in which all of the following are recognized as ending a line: the Unix end of line convention \n, the Windows convention \r\n, and the old Macintosh convention \r. See PEP 278 and PEP 3116, as well as bytes.split lines, for an additional use. Variable annotation. An annotation of a variable or a class attribute. When annotating a variable or a class attribute, assignment is optional. Class C. Field annotation. Variable annotations are usually used for type hints. For example, this variable is expected to take int values. Count, int equals 0. Variable annotation syntax is explained in section Annotated Assignment Statements. See function annotation, PEP 484 and PEP 526, which describe this functionality. Also see annotations best practices for best practices on working with annotations. Virtual environment. A cooperatively isolated runtime environment that allows Python users and applications to install and upgrade Python distribution packages without interfering with the behavior of other Python applications running on the same system. See also VNV. Virtual machine. A computer defined entirely in software. Python's virtual machine executes the bytecode emitted by the bytecode compiler. Zen of Python. Listing of Python design principles and philosophies that are helpful in understanding and using the language. The listing can be found by typing import this at the interactive prompt.